Hello, everyone. May we have your attention, please? Please leave your mobile. Those are not going to go anywhere. So give us chance that we have presented some topic for you. Let us present to you. A quick introduction. I'm Shweta Vohra. I'm presenting this cell-based Kubernetes. It's a weird term. It's a new term we have coined, cell-based Kubernetes. It's based on cell-based architecture. About me, I am architect, inventor, and author. I believe in this statement called don't just build platforms, create legacy. I believe in it so much so that I have written a whole book on that. And this book is a India premiere of this India launch. So you will have opportunity to grab the book. Stay tight. I'll be announcing few things towards the end. And with that, let me give it to Saiyam to introduce himself.
Hello, everyone. My name is Saiyam Pathak, and I work as a principal developer advocate at Loft Labs. I'm the founder of Kube Simplify, simplifying cloud native, and Build Safe in the supply chain security area, creating zero CVE base images. You can reach me at Saiyam Pathak on all social platforms. I'll try to reply in between the session, but after the session, yes, definitely will do.
Perfect. With the introductions done, let's jump on to the topic. Simple agenda, cell-based architecture and Kubernetes implementation nuances. Let's start with a question. This is a question which came to me a couple of months ago, and this is from Sai Ranganathan, and thankfully he permitted me to show this question here. So he said, I'm trying to figure out, can we have the Kubernetes pods inside a cell and GLB at the network layer? Will it be costly operation? So this question has a lot inside it. But before we delve into this particular question, I want to tell you about a few things. If you are new to cell-based architecture, then this is my third session in this series, and all three of them have been luckily given in the KubeCon community. So first one happened, the Cell Basics and Booking.com, because I'm an employee of Booking.com. We presented that use case along with my colleague in KubeCon Paris, and this is the QR code where you can grab it and listen it. That's the most basic, as well as the bookings use case of what we do with the cell-based architecture. Then second, I presented on industry use cases that apart from that, what are the use cases where you can use it? It's not an architecture where you can use it anywhere, everywhere. So there are selective use cases, and if you have any beyond it, I'll be curious to know about that. Then third one, this one we are presenting on the demystifying cells versus various entities and cell-based Kubernetes implementation. So let's get started. Cell-based architecture comes from the cell. Cell is very, very fundamental unit, much older than us and the life on Earth. So it starts with a cell. Cell is the smallest unit of life. Each biological cell composed of various organelles. We all know that. And each cell is responsible for creating its own energy, production, consumption, and metabolism. This is very simple. Where else we have used it? We have used it in mobile cellular architectures, where each cell, we geographically align them into smaller regions. And then we use the various spectrum of bandwidths to be spread across in these cells. And that's how they don't interfere with each other, as well as seamlessly operate, because this design allows efficient use of radio spectrum and provides consistent coverage for mobile users. And this is also a known pattern, but in cellular architecture, they are much more advanced than we are in the cell-based architecture in softwares. That's a topic for later discussion, but now let's delve into cell-based architecture, what it means to the software world. Now, cell-based architectures, definition-wise, it's a software architecture approach that leverages the concept of logical grouping of software components into cells. And catch here is based on your business context. Because every software we create is a logical grouping in some form or the other. But if you are creating a cell based on your business context, then that can be called as cell. It's not that you will put anything and everything in a cell, and that will become a cell-based architecture. We'll go into these details now. But before that, I always emphasize, and this might increase in future more, but These are the 4 principles which I would say that if you don't grab anything else from this session, then at least these 4 principles keep in your mind. The first one is that cell, whatever you create, is a self-contained unit. What all you can put in components, we'll be discussing in a minute. Independently scalable. So if, let's say, I've decided to put a couple of microservices in my cell, then we have to make sure that it is independently scalable. One thing is dependent on other, so this has to be considered as one unit. Then maintain the clear communication boundaries, because if you're not doing that, any sort of communication you are doing between the cells, then you're diluting all about the cell-based architecture. So clear communication boundaries are must for any cell-based architecture. Cells are designed to be the smallest deployable and manageable units, because the more and more we have infrastructure as services, everything as a service, it should be deployable and manageable together. So that's the 4th principle which you should keep in mind. With that said, let's come back to the question of Sai. He says that Kubernetes pods inside a cell. Do you think it's possible with a raise of hand? Anybody thinks? Okay, I can see 2, 3 hands only. What about few more are going up? Few more, okay. So this is the topic for the slides further, but I quickly want to touch upon the rest 2 topics, which is GLB can be at network layer. So GLB is the global load balancer, what he means. Global load balancer means when you have cells and you're talking to these cells, it is ideally done through a networking layer, which we'll be seeing in a diagram also. But that's where he meant that, can I call all my cells through that GLB layer? Answer is yes. Will it be a costly operation? So cost is a magic. I'm not trying to touch upon the cost topic here, but cells comparatively to other components become costlier. So yes, it is costly. So you need to be very careful where you really need those use cases where cell-based architecture should be used. With that said, let's compare what is microservice versus pod versus cell. I'll talk about microservices versus cell first. So where microservice, granularity is the first thing where these 2 things are different. How a microservice differs from a cell in granularity. Microservice is a entity which tries to attack on single function, where we always say that you should have microservices which serve a single function. And cell tries to have multiple components inside it. So you can have multiple of such microservices and related components inside a cell. So it is a little bigger entity than the microservice. Scope and autonomy. So scope of microservice is limited to that single function, whereas cell provides you within your business capability and your business context what scope you want to build into your cell. For example, you might want to have order inventory, payment service as your cell, where payment service can have more components to it, and that is what you will use as your cellular architecture. Whereas microservice will only have one particular function to do, or scope. Scalability, microservice scales at the service level, cell scales at the cell level. That's where it's complexity-wise, it's multiplier effect. And the 4th thing is isolation. Now this is very important, because if we are not successfully separating out these cells, we are not doing the right job. So microservices prone to cascading failures due to inter-service dependency. That's why we have pods. Why we created these pods at all? Because of creating this separation. So that's why containerization, pods, and Kubernetes, the whole world is here. Whereas cells do the strong fault isolation, communication externally via APIs for events or messaging. So that's the pattern we use. Delving further into it, let's pick up an example so that all these concepts, what we have said, you should be able to relate it to a practical scenario. Let's say we have a payment service which is doing the business logic of payment, validation, processing, fraud check. 3 functions in that one microservice it's doing, but related to all payments, so we'll still call it one function. It has its own database. It interacts through API interface. Next service I have is metric service. Now, what does this metric service is doing here in this scenario is that it collects and aggregates real-time metrics from various sources, and it puts it into various visualization interfaces. It also gives you a bit of in-memory database, and of course, event streaming from there on, so that it keeps everyone informed and alert. Third service I'm picking up is notification service. Now, this notification service manages, in this particular scenario, various types of notifications and templates and scheduling logic for that particular payment service. It also has a minimal of database and API interface. Now, I'll be asking few questions a bit alert. And I'm not going to move forward till the time I get yes or no. This is the cell design option number 1, where I'm saying, shall we make one common cell of these microservices? Those who say yes, please raise your hand. No one. OK. Those who say no, please raise your hand. Amazing. So, well-educated audience I have. Great. No, so you're right. Why this is not a right pattern? Because this has certain weaknesses as per cell-based architecture. This lacks the domain cohesion. So if I put all of them in a cell, it means I'm doing a monolith. We don't want to go that route, right? We have come all the way for microservices, and then we mess up with these things and come up with, again, monolith. Scalability will be a concern, because you cannot scale everything on cloud all together. Then fault tolerance will be a big issue. OK, option number 2. Shall I make 3 cells, cell 1 as payment, cell 2 as metric, cell 3 as notification? Is that a good pattern? Yes? I can see few hands raised. OK. Now, those hands who say no, this is not right. OK, so I can see mix of the audience. 50% are saying yes, and 50% are saying no. Those who are saying no are right, because if you make 3 cells, then it means you are creating a burden. Already you have a microservice. Already you have a pod. You are in Kubernetes cluster. Your pods are scaling independently. Why in the world you need a cell for this if you have to scale them separately, right? There has to be some reason to make them as separate cell, which may be in some scenarios valid, but in most scenarios not. So if you are using it, it means this is a misuse, and you're overkilling the resources. So you must have lots of money to waste. That's why you would opt for this scenario. Let's look at third scenario. We are making cell 1 as payment cell, where payment and notification are seen here, and cell 2 as metric cell. Any one of you feel that this is right? A lot of you. So great. This is the right pattern, and I'll tell you why this is the right pattern. Because it is based on domain alignment. It combines your payment and notifications together. OK, let me move on to the next slide where I have all these reasonings. Yes. So cell grouping. So we are making, why this approach? Because domain cohesion-wise, this cell works. If you would have heard the services where I explained each of these services, the payment service does the payment part of things, where it interacts with the outer world to take various payments. But when it interacts with the inner world, it interacts through the notification service. And that's why, if payment service alone you will make a cell, and notification service is lying anywhere else, even if your payment cell thrives and notification service or the cell is not there, your system will fail. And that's where you need these to be combined into one cell. So hope now you see where it differs from microservices, right? And metric cell, because metric cell is something which can be used in, it's an infrastructure-related service which can be used by multiple business functions. So you would preferably want it to be a separate cell, because we don't want payment to be dependent on my metrics. It's a secondary function. OK, so this is the right approach. Let's look at the implementation of it. So let's say this is my payment cell, where service 1 indicates my payment service, and service 2 indicates my notification service. In this case, my both services are sitting together with its ingress gateway, egress gateway, lots of security things which Saiyam is going to delve on SPIFFE, OPA, and Keverno, and other database, Lambda, etc., whatever components are required to make this cell work. Now, if you notice, I have these cell instances as cell 1 in AZ1, cell 2 in AZ2, and cell 3 in AZ3. Why this? Because that's where I want to achieve my resiliency of this critical function in my business context. So I want to separate it out, whether it is at the availability zone level or whether it is at the regional level. Next is my metric cell, where microservices, database, visual interface, whatever is my functionality running into this particular cell. This also maintains a lot of security constraints and the boundaries. However, this cell is not critical for the business functionality, so I might decide to run it into just one cell or maybe two across the AZs. And this is where the global load balancer question of Sai comes in picture, where here we are saying, have a separation of networking infrastructure, have the networking routing layer separate. And there you will see you have cell router, cell registry, because how would you decide? If I have to, something I'm getting from a payment from the user, this has to decide that which cell this has to be routed if all three are functioning in parallel or in primary, secondary mode. So that's where a lot of other components come at the network layer as well. Overall, this diagram, a bit of it looks like this. There are more things inside it, which we will see in demo. But overall, we have payment cell, metric cell, we have notification, networking, network routing layer, and there are few more like observability you want to maintain, deployment you want to maintain, those can be your separate cells. So this is how a typical organizational or business logic around cell-based architecture looks like. With that said, this use case is over, and I'm going to give it to Saiyam because he's going to show us his experience as well as more intricacies of the implementation through a demo. Over to you, Saiyam.
So I think you now got a gist from the very basics of what cell is and what a cell-based architecture within Kubernetes ecosystem would look like. So Shweta mentioned some of the very key concepts. Isolation is one, cost is one, segregation of cell is one. So we'll be trying to see a use case and the implementation in a way where we'll be creating the virtual clusters, and we'll then be using some of the concepts like Kyverno for the security, and then you saw the payment and you saw the metrics, which can be used by other cell components as well. So basically a shared platform stack which is there, which can be used by other cells. So let's try to understand how things should work. So let's first check the internet connectivity. And also this is a live demo, and it worked a few hours ago. You have to trust me, if things fail here, it is still working. So right now, this is a plain Kubernetes cluster. So what I'll be doing now is I'll be using a tool called vCluster, and we'll be creating a virtual cluster. So would not dive into a lot of things what a vCluster is. It's on a very high level. It lets you create virtual Kubernetes cluster. So here what I'm trying to convey is, within a single Kubernetes cluster, you are having multiple virtual Kubernetes clusters that I'm labeling as cell, because those will be having your application set of things. And then there will be some shared platform stack like cert manager, ingress controller, Kyverno, which can be used across different cells. So you'll be able to use the cert manager, ingress controller, and Kyverno policies throughout the different cells. So you maintain that isolation, which is pretty critical. You have heard that from Shweta as well. So you maintain that cell boundary, which is very critical, and you keep the costs low, because you have to think about how the costs would be. So covering all these three, let's try to create virtual clusters. So first I'll create, because it takes some time, and then I'll explain some of the files that I've used in that. vCluster create KC demo 1, and I'm giving a vCluster YAML file. I'll show you what is there in that particular file. And we'll create another cluster, vCluster create KC demo 2. And here I'm not passing anything, I'm just creating a bare virtual cluster. So what is there in the files? So this is the vCluster.yaml file. What it says is, I want to create a virtual cluster, but I want to sync some of the resources, some of the custom resources. Because Cert Manager installs some CRDs, Nginx controller, you have ingresses. So you want to sync the ingress, you want to sync the certificates, you want to sync the secrets, and then there are some of the patches that you want to do. You want to sync the issuers, because these are the CRDs that get installed as part of the Cert Manager. So it is creating, and when it creates a virtual cluster, it runs a Helm kind of command. And what we'll do is, so this is the host cluster, and let's see what all things are there on the host cluster. So on the host cluster, I already have a few things which are installed. I have Cert Manager, one thing which is already installed. I have Ingress Nginx controller, which is installed. And these are regular components which came by default with the cluster, and I have Kyverno installed as well. So Kyverno is basically a tool that lets you create Kubernetes policies. Let's say you do not want your team to pull from XYZ registry. So you can, create a policy for that, so that everyone in your team follows that and they're not pulling an image from a particular registry. So like this, there are, n number of policies that you can create using Kyverno. So what we'll do is, and let's see what the cluster policy we'll be using. So what we want to do is, we want to restrict node port. So what we want here is, we do not want any of the cells to be able to create a node port service. So, but we'll be creating this, and Kyverno is installed on the host cluster. Kyverno is installed on the DigitalOcean host cluster, and it is able to identify whether we are creating a node port service or not. But we want this same policy to be used by the cells as well. Like when we are trying to create within a cell a particular node port service, it should fail. So this becomes a shared platform stack. So here the shared platform stack would be Ingress controller, Cert Manager, Kyverno for the policies. So you can see both of the virtual clusters are up and running. It should have switched the context as well. Let's see which Kubernetes context we are currently in. kubectl config get context. So we are in the demo 1. So demo 1 was created using that vcluster file. So the Cert Manager demo will be happening over here, so which is fine. Let's deploy a simple application. It's an Nginx deployment with a cluster IP service. So this is pretty simple. kubectl apply -f app, kubectl get pods. So our application is running, kubectl get svc, service is running. Now we'll be creating the issuer. So for Cert Manager and HTTPS, you just create the issuer with the solvers as HTTP01 and the ingress class as Nginx. So you have the issuer, and then you create ingress, and ingress just using nip.io. I hope it issues the certificates and it doesn't say that you have used too many certificates for this. So yeah, for the TLS and the host. And lastly, we'll create a certificate. Again, I want to issue the certificate for this. So kubectl apply -f certificate. So kubectl get ingress. So we have the ingress kubectl get certificate. Certificate is already true, so demo ran without any issues, which is good. We can see that running. So this is how the isolation would work. Now, whatever is deployed in this particular cell, in this particular virtual cluster, will not be able to see in the other virtual cluster, and we'll be able to deploy our own workloads, own set of microservices in the other virtual cluster. But we'll be using Kyverno over there, because we still want to use the shared platform stack. So kubectl config get context. So let's switch to the admin cluster first. kubectl config use context admin, and kubectl get ns. So the demo 1 cluster is this. It creates a namespace, kubectl get pods -n. This is how it looks like on the host cluster. On the host cluster, it creates the virtual cluster is just a stateful set with its own control plane, etcd, controller manager, all that stuff. So let's apply the cluster policy. So this is the cluster policy. Now the cluster policy is what I have created on the host cluster. Now switch back, let's switch to the demo 2 cluster context. So we'll switch now to demo 2. kubectl get pods -a. And you can see in demo 2, it's a fresh one, so it doesn't have anything. And when I'm in that context, I'm not able to see any of the stuff which we deployed, certificates, secrets, and ingress, application, service in the demo 1 cluster. So we are not able to see anything over here. So let's try to run a pod. -image, nginx, it should work fine, everything is working fine. Now let's try to create that node port service and see if that gets created. kubectl create service node port kc demo -tcp, and it says, yeah, that there is a validation. So our shared services and the security boundaries are still respected by the cells. So we are saying that cell is a virtual cluster over here, and within the cell context, we are still able to use the policies that are applied to the cluster level. So you can have the n number of Kyverno policies. You can have Falco for the runtime security. So you can install Falco on the host cluster, which creates a daemon set across the Kubernetes clusters. And if you our V clusters would also respect the Falco rules, which are defined when you do install Falco over there. So that's pretty much it about the demo. And this is the repository, KubeCon India. If you want to try things out, I have tried to mention these steps as well. Installing Cert Manager. I just created just 2 hours ago. I added all of this. Ingress controller, creating 2 virtual clusters, applying all the files in one cluster and see how it works, how the segregation works. And yeah, that's pretty much it from the demo. And over to you.
Yeah. We'll now take questions, and just for everybody's benefit, book is available on Amazon. I'm so happy to tell you. And you have opportunity to grab it on this QR code, as well as on the CloudFuse booth. CloudFuse is all about the comprehensive observability tool. They are at booth number S26. And book signing will be happening from 1:30 to 2:30 today. So grab your copy. And if you have any questions, we still have time. As we can see, we have a few minutes. Any questions, we are happy to take. Yes, please. I can hear you. I'll rephrase your question once I hear it.
No, this is just one reference implementation. So what happens is you can have a different set of implementation. Shweta showed one architecture, and I showed a different kind of architecture with different set of implementation. But the overall ideology, yes, pod is not something that you consider as a cell. Isolation, that is very critical to the cell. There are certain set of services that are contained with the cell that you can scale, and there are certain set of services that should be shared across the cell that they can use. For example, the metrics one was being used by the payment one, and in this particular case, Kyverno was being used by the underlying virtual clusters. So the question was basically, is this the only implementation that I just showed? So it's the answer is no. There are other reference implementations.
Is your question that can we have multiple clusters in one place? Right. So, so that is what I have covered in the second presentation, which I gave in Salt Lake City. I would highly encourage to view that, but I'll give you a short answer to that. So there are few very pertinent cases where industry is using it. As I said, one of them, for example, in Booking.com, we use it for security. We have a big fintech work going on, and where, let's say, payment is very secured way, and we cannot afford to fail there for the payments. So we have created cells where cells are logically tightly coupled entities. They go on cloud together. If they are going down, they're going down. So if one cell goes down, there is another one to pick it up. So we want to create this logical entity around it, and that's why we are using cell-based architecture. I've seen AWS, in fact, recently, Dr. Werner Vogel has encouraged people to use cell-based architecture as one of the things. AWS is highly promoting it for their resiliency use case, for the regional and the AZ use cases. But then I have seen some people are using it for their domain boundaries. For example, one cell is the responsibility of this product team, where they are working on a particular feature and they have product as a segregation, not any other things. So that's another use case. And that's where all the use cases which I've touched upon, you will get there in that presentation.
Last question.
Okay.
So when you're applying a cell, can I say cell in itself is cluster?
That can be another talk. Cell can itself be a cluster. I think cell is broader than cluster because you won't only run cluster. You need some database. You need some communication, let's say Kafka, event streaming, etc., etc. So cluster is just one component which will sit in your cell. I mean, there would be very unlikely case where just a cluster sits in a cell and nothing else. Sorry, I'll just take his question. He's already there.
So the logical separation and the grouping of like pods, etc., whatever, into a cell can also be probably done by using base native Kubernetes constructs like network policies and limiting request limits on the namespace and policies as
Absolutely. That's the fourth level of, actually, if you ask me, the presentation where we would like to tell world more because this information is not available. All the high-level information about cell-based architecture, which people may or may not understand, but that's the fourth level, and those are the constructs you will use to actually do the implementation.
cluster, like I think it adds just one more, like I feel that it is useful in two cases where either you need to test your CRDs, you want to install different CRDs or you want to test different Kubernetes versions. That is where I think vCluster can help. Other than that, like is there any
So, I mean, I mean, his question is that vCluster's usage in the cell-based architecture context. In my view, I resonate with your view. In test scenarios, in development scenarios, it is good to have. In production scenarios, may not be. But let's hear out it from, because he's more experienced.
Probably I can give you a lot more information and demo if you come to the booth. But in a gist, vCluster is actually used across production, fintechs, healthcare, everywhere. And vCluster not only creates, it helps you with your multi-tenancy use case where you want to have multiple Kubernetes clusters within the same cluster. So basically reducing the number of clusters is one, and putting it as a central part in your platform engineering space where you have a simple like every team requests for a cluster and they get a virtual cluster out of that. So that would be another use case. So basically cost saving is the biggest advantage of vCluster. And if you want the differences between the namespace level isolation that you saw, network policies and stuff, and with vCluster, we can chat more on that.
We still have 1 minute, and let's take one last question. You mean to say within, so is your question that in a cell, if people change the configuration and mess up with some things, then how would it work? Is that your question? Yeah.
The impact isn't wide, right? But what if there is this very critical impact? So how would you ensure that this doesn't happen?
I would encourage you to look at that Salt Lake presentation where I've given all these best practices with the application, data, infrastructure, and networking, 4 areas. Because you would have to do the cell versioning. If at all you feel, and even the configuration shouldn't change, there are certain best practices around it. Yes, if you're taking cell as your, something in your organization, you need to know about those best practices, which will make sure cells don't cross their boundaries where they're meant to be, whether at network layer, data layer, application, and infrastructure too. So that is covered in that. I would encourage you to listen that, please. I mean, answering that in short is not possible. So please do listen that. We can take it offline. Time is up.
Time's
and
up.
we have to give it back to them.
I mean, we are
Thank you
seeing
so
that
much
on the
for
screen.
listening.